Okay, so just a few questions for you. If a house can be painted in 6 days, how much of the house will be painted after the first day? 1/6, exactly. The house can be completely painted in 6 days. 1/6 of the house will be painted after 1 day. What about after the second day? How much of the house will be painted? Philip.
1/3.
Yep, so it would be 2 out of the 6 days, right? Which simplifies down to 1/3. All right, what happens if we want to figure out how much of the house will be painted out of after X days? What should we do? How would we represent that? James?
Like x over 6.
X over 6. All right, how about after 6 days? Wouldn't it be 6 out of 6, which is 1 whole? Okay, so a lot of these word problems are going to be dealing with jobs and completion of jobs. And the reason I did this little preview here is for us to know a total job is completed when it equals 1. One whole job is completed. So it takes 6 days to paint. After the 6th day, it is completed. Numerator equals denominator. That is a completed job. Okay, so a little hint for you, and you'll understand once we start doing this. All right, when people are working together, I have decided let's always let the numerator be the time they do the job together, and the denominator will be the time they do the job alone. So the numerator will be the time they do the job together, the denominator will be the time they do the job alone. For example, you guys don't have to write this down. I'm just showing you because this isn't going to be the process. So let's say, Sally can clean her room in 4 hours. Billy can clean it in 2 hours. How long will it take them to clean together? So I'm just showing you something. So basically, we want Sally plus Billy will equal the total job. Now, I told you a total job is going to be 1 whole completion. So we're going to be dealing with fractions. So if I said Sally can clean the room by herself in 4 hours, that's the denominator, her time alone. Billy can clean the room in 2 hours by himself. And their time together, we don't know. So time together, I'm going to let be X. Now, this makes perfect sense. When we're doing these problems, we're going to eliminate the denominator, but I want to just create a common denominator just to show you. If Sally can clean the room, or together, together, the time will be a fractional part out of 4 hours. It's going to be less, right? It's going to be less time than the 4 hours. If I were to make a common denominator of 4, this would be x over 4, and then 2x over 4 equals the total job. Doesn't this make perfect sense? If Billy cleans the room in 2 hours and Sally cleans it in 4 hours, that Billy's time, he will be quicker. He'll be double, he'll clean this room so much quicker than Sally would. So he's going to be 2 times faster than Sally. So that's this whole idea of numerator over denominator. We're not going to do this problem. I just wanted to show you that whole idea of the time alone versus the time together. Okay, James, you're famous.
Yep.
You're welcome. I've made you famous. So James and Kenny mow the lawns on their block. James can do the job in 12 hours alone, and Kenny takes 24 hours in total to complete the job by himself. If they work together, how long will it take them to mow all of the lawns on the block? So I'm going to say let X equal time together. And we're going to take James plus Kenny, and that's going to equal the total job. Okay, now what was my advice to you? What are we putting in the denominator? Time alone. Time alone is in the denominator. So how long will it take James if he had to do all the mowing by himself? 12 hours. How long would it take Kenny if he had to do all the mowing by himself? 24 hours. And what is the total job always equal to? One whole complete job. Do we know how long their time is together? No. So we're going to say X and X. So now what I'm going to do is I'm not going to create a common denominator. I'm going to eliminate the denominator. How do I eliminate the denominator? Multiply everything by 24. So we're going to 2x plus x equals 24. So what does x equal? 8. What does that 8 represent?
Time it takes them to do it together.
Yeah, minutes, days, hours, what? Hours. It's going to take them 8 hours together. X will represent 8 hours together. Okay, next one. Okay, so this one says, Barbara takes 6 hours to clean her room. If her brother helped her, it would take 4 hours. So now, well, let's keep reading. How long will it take her brother to clean the room by himself? So I have Barbara's hours alone, and what else do I have? Philip?
Time it would take for both of them to do it together.
Good. I have their together hours. So I have Barbara alone. I have their together hours. I want to know how long it would take the brother by himself. So we know Barbara, BA, plus brother, BR, equals the total job. So Barbara will take 6 hours alone. How many hours together? How many hours together? James?
4.
4. Do we agree both numerators are 4? And then we don't know how long it will take the brother alone. So I'm going to put X there. Can I simplify the 4 over 6?
Yes.
Yeah, I can simplify it down to 2/3. Now I'm going to multiply everything by 3x. So we're going to have x plus 12 equals 3x. So we're going to have, right? X plus 12 equals 3x. Does that look right? Yes. No, 2x, sorry. 2x plus 12 equals 3x. So we're going to get that x is equal to 12. What does this represent? Tejas?
12 hours to take the load.
Good. 12 hours for the brother to clean the room by himself. All right, number 3. Ned, Ethan, Jim, and Bill are loading a truck to make deliveries to upstate New York. Alone, it would take them 10, 16, 15, and 12 hours respectively. If they work together and begin loading the truck at 10 a.m., when will the truck be ready to make deliveries? So now we have 4 people working. We know Ned plus Ethan plus Jim plus Bill will equal the total job. What does 10, 16, 15, and 12 represent? What does 10, 16, 15, and 12 represent? Same hands every time, James?
The time it takes them to like load by themselves.
Load. Good. These are their alone times, right? So where do the alone times go? Then alone times where? I think I heard it. Tejas? Denominator. The alone times go in the denominator. What about the time together? Do we know the time together? No, if we don't know the time together, what should we put? X. All right, I'm going to multiply everything by 240. On both sides. And if we do that, we are going to get 24x plus 15x plus 16x plus 20x equals 240. Which brings us to 75x equals 240. So x will equal 3.2 hours. I was not asking how many hours. I was not asking how many hours. What was I asking for? Philip? Yeah, I'm looking for a time. So they're saying they're going to start loading at 10 a.m. What time will they be finished? If they start loading at 10 a.m., what time will they be finished? Well, we know we're definitely going to take 10 and add 3 hours to that, right? But I'm not going to say 0.2, right? What do we have to change that 0.2 to? 0.2 hours to what, Philip? Minutes. How do we do that? Well, do we all agree that 0.2 is equivalent to 2/10? And 2/10 is equivalent to 1/5. So we have 1/5 of an hour. Well, an hour is how many minutes? 60. So I'm going to do 1/5 times 60. And when we do 1/5 times 60, we get 12 minutes. So now we are, x is equal to 3 hours and 12 minutes. So what do I do with that 3 hours and 12 minutes to find the time they finished loading that truck? Michael? Good. So 10 hours plus 3 hours and 12 minutes brings us to 1:12 p.m. All right, ready for the first one? Ned can mow a lawn in 75 minutes and Pedro can do it in 50 minutes. If Pedro watched Ned for 20 minutes, then it helps to finish the job. Find the total time for the job. What's wrong, Philip? Why are you so theatrical right now?
It seems confusing.
I got you. I'm going to help you through this. All right. See? Don't be scared. All right. So we are mowing lawns. So we have Ned plus Pedro will equal total job. Do we agree? All right. Ned can mow the lawn in 75 minutes. Where is that going? Top or bottom? Numerator or denominator? That's 75. Ned can mow a lawn in 75 minutes. That's him by himself. All right. Denominator. Pedro can do it in 50 minutes. Where's that going? Numerator or denominator? Denominator. Okay. if Pedro watches Ned mow the lawn for 20 minutes, then helps to finish the job. Right, so when they're working together, are they actually working together for the whole time together? No, somebody's working longer. Who's working longer? Ned is working longer. So if I let X equal time together, that means Pedro worked X, right? He only worked that time in the numerator with Ned. But Ned did the same amount of time as Pedro plus an additional 20 minutes. So we can either say that Pedro is X and Ned is X plus 20, or if you wanted to, you can say Ned is X and Pedro's X minus 20. Either way would have worked, and you're going to get the same answer ultimately at the end. Philip, is that what you were going to ask? All right, we're actually going to do a little bit more work than you, our way. So you're going to get the answer quicker than us. But in my mind, this just made more sense. All right, so let's cross multiply. So we have, not cross multiply, eliminate the denominator. So I'm multiplying by 150. When we multiply by 150, we are going to get 2 times the quantity of X plus 20 plus 3X equals 150. Distribute in that 2. 2X plus 40 plus 3X equals 150. We have 5X equals 110. X will equal 22. I'll let you all catch up. All right, find the total time for the job. 22 is not the total time for the job. Why? Danny?
Is it 20 less than what it's supposed to be, like the time?
Exactly, because we said X is just their time together, but that wasn't the total time spent on the job. Why? Because didn't Ned work an additional 20 minutes by himself? So the total time is going to be 22 plus 20, which is 42 minutes. Okay, work crews A, B, and C can pave a road in 10 days if they work together. So what does the 10 days represent? Their together time. The 10 days represents their together time. So crews A, B, and C can pave a road in 10 days if they work together. If they work alone, crew A would take 60 days to do the job. Crew B would take 3 times as long as crew C to do the job. How long will it take crews B and C to each work alone? So we know A plus B plus C will equal our total job. What are all of our numerators going to be? Michael? 10, you got it. So crew A would take 60 days, so the first denominator is 60. But then it says crew B would take 3 times as long as crew C. So if I'm going to go to crew C and call them X, how would I represent crew B if they're 3 times as long? Tori? 3X, you got it. Can I simplify 10 over 60 down to 1/6? Yes. All right, what am I going to multiply everything by? Oh, what did I do here? This should be a plus. What should I multiply by? 6X, good. So we end up with X plus 20 plus 60 equals 6x. So we're going to have 5x is equal to 80, so x will equal 16. What does 16 represent? For who? Crew C equals 16 days. What about crew B? Danny?
48.
48 days, you got it. Oops. Okay, next one. Tammy is filling her pool with 2 hoses. The larger hose can fill the pool by itself in 10 hours. The smaller hose can fill the pool in 15 hours. Tammy left the drain open in the pool, and it can drain the whole pool in 20 hours. How long will it take before the pool is filled with both of the hoses running and the drain opened? So do we agree the 2 hoses are working together to fill the pool? But what is the drain doing? Philip? It's taking out the water. So hose 1 plus hose 2 are working together, but the drain is working against the hoses. So what's going to happen? We have hose 1 plus hose 2. They're going to be adding because they're working together, but the drain is not going to add with them. The drain is going to do what? Subtract. So minus the drain will equal the total job. Okay, Tammy is filling her pool with 2 hoses. The larger can fill the pool by itself in 10 hours. That's a 10. The smaller hose can fill the pool in 15 hours. That's a 15 hours. The drain can drain the pool in 20 hours. How long will it take before the pool is filled with both of the hoses running and the drain open? So basically the time together is unknown, so this is all x. We're going to multiply by 60 everywhere. And we are going to end up with 6x plus 4x minus 3x equals 60. If you solve this, you're going to get 60 over 7. Did I say at what time will it finish? No, what did I ask? How long will it take? So if I were you, I would not change this to a mixed number. I would not change it to a decimal. I would not change it to hours and minutes. I would say it would take 60 over 7 hours. That's what I could do. You can change it to a mixed number. You can change it to hours and minutes, but it's not worth it. Yes. Yeah. All right, I want you to try number 6 on your own. Try number 6 on your own, but I will give you a hint, okay? I would, if I were you, when it says the largest pipe alone takes 1/3 the time of the smallest pipe, I would let the largest pipe be x. I wouldn't let the largest pipe be 1/3 x. That way you're not dealing with a fraction. So if I were you, I'd have the largest pipe be x. Well, if the largest pipe is x, and that's 1/3 the smallest, that means the smallest is what in comparison to the largest? If the largest is x, then the smallest is, Tejas? 3x, right? If the largest is 1/3 the smallest, then the smallest is 3 times the largest. Yes? No? Y'all look confused. All right, try the problem. We'll go over it. All right, who has some answers for me? Who has some answers for me? So we have, where are they? Small, medium, large. What did we get for the amount of hours for the small? Will it help if I tell you I got an improper fraction? Arav?
For the small part, I got 11 over 2 hours.
11 over 2? I got that for the large.
Oh.
I got 11 over 2 for the large.
Oh, sorry. I had that for the large. For the small, I got 33 over 2.
Good, 33 over 2. What about the medium? Tejas?
11 hours.
11 hours, you got it. How many people got that?
Wait, 11 for the small.
No, small is 33 over 2.
What did you for the large?
The large was 11 over 2. Clearly we need to do it. Yes? Okay, let's do it. Okay, if 3 pipes are all open, they can fill an empty pool in 3 hours. So do we all agree these 3 pipes are all working together? So we have pipe 1 plus pipe 2 plus pipe 3 equals total job. Or I should say, since we have large, medium, small, so we are going to have large plus the medium plus the small. Right. If 3 pipes are all open, they can fill an empty pool in 3 hours. So their time together is 3. The largest pipe alone takes 1/3 the time. So I told you, my hint to you was don't use fractions in the denominators. Just call the larger pipe X. So the largest pipe alone takes 1/3 the time the smallest. So if the largest is 1/3 the time, the smallest is 3 times the largest. And takes half the time of the medium pipe. So if the largest is half the medium, that means the medium is double the large, which is 2x. Now we multiply everything by 6x. So we are going to get, was it 6x? Yes, it was 6x. So then we are going to get 18 plus 9 plus 6 equals 6x. Combine our like terms, we're going to get 6x is equal to 33. Divide by 6. We get x is equal to, simplify this, 11 over 2. Remember, x was our large one, right? So large equals 11 over 2 hours. The medium is going to be 2 times 11 over 2, which is just 11. And the small is going to be 3 times the large, which is going to be 33 over 2. Kai, you good?
Yeah, I got it.
Okay.
I just didn't put it in right. I didn't plug it back in right. I got all the answers.
Okay. All right. Distance formula. We've done this before. We've done distance problems. We're just going to do them in a different way now. So somebody tell me who remembers what the distance formula? D equals what times what? Distance equals, Philip?
R times T.
You got it. Rate times time. All right, if we want to solve for R, so we want to get R by itself, do we agree it's going to be R is equal to D over T? And if we want to solve for T, what is that going to be? T is equal to D over R. All right, the Peng family drove from their home into the country at a speed of 80 kilometers per hour. They returned over the same road at 70 kilometers per hour. If the round trip took 6 hours, how far did the Pengs drive to the country? All right, so question for you. They said the round trip, meaning to the country and back home, took 6 hours. Can I just say, okay, well then it took 3 hours going there and 3 hours coming back? Can I do that? Why no? Noah?
Because they're going at different speeds, so it could take different time.
Yeah, so they're going at different speeds, which means they're going to take different amounts of time. The faster speed will be less time. So what I'm going to do is I'm going to set up my chart. And we're going to talk about going to the country and then back home. Now, the only thing we're certain of is the rate, right? We know their rate. And the rate is in kilometers per hour. So the rate to the country was 80 kilometers per hour. And the rate back home was 70 kilometers per hour. We don't have to put the km per hour. We already have it, 70. Now, the old way we would have done this, which would still work, if you put the time, one way is x, and then the other way is 6 minus x, right? And then the distance is rate times time. You can do it that way, but I'm going to do it in a way that involves fractional. I'm going to do it in a way that involves a fractional equation. So what I'm going to do is I know the rate, which I laid out there, and the one constant thing that we don't know, but we know it's the same, is the distance, right? They took the same route. The way there and the way back was the same kilometers, the same amount of kilometers. So we know that no matter what, it's the same. So if I call the distance to the country x, the distance back home will also be x. Right? We do not know the time. We do not know the time. So we're going to say time. And remember, the time is going to be d over r. So the time to the country will be x over 80. The time back home will be x over 70. But what do we know about the time? The time there and the time back will equal how many hours? 6. So now my equation is going to be x over 80 plus x over 70 equals 6. And I'll write it out. Time to the country plus time back equals 6. All right, if we multiply everything by 560, if the round trip took 6 hours. So we're going to multiply by 560. I'm just going to jump to our answer here. We're going to get x is equal to 224 kilometers. Okay, let's get to the boat problem. A boat can travel 20 kilometers per hour in still water. It can travel 47 kilometers downstream in the same time that it can travel 33 kilometers upstream. What is the rate of the current? So I'm going to let x equal the rate of the current. But now let's just chat about this for a minute. All right, when you're in still water, what does that mean? There is no what? There is no current. So your speed is basically on the amount you work on your own, right? It's all you can do. Now, if you're going downstream, is the current helping you or is it making it more difficult for you? Downstream, it's helping you. The current is helping you. But what about if you're going upstream? Is it going to help you or is it going to make it more difficult for you? It's going to make it more difficult because the current's working against you. It's not working with you, it's working against you. So it's your work versus the current's work. All right, so what are we going to do? I'm going to set up my chart. We have downstream and upstream. We have the distance. We definitely know the distance, right? So it says a boat can travel 20 kilometers in still water, right? That's not upstream or downstream. It can travel 47 kilometers downstream. So our distance is in kilometers. So we're 47 downstream in the same time that it can travel 33 kilometers upstream. So upstream is 33. Right, what is the rate of the current? So the rate is also, not kilometers. The rate is going to be hours. Well, kilometers per hour too. It doesn't matter. Be kilometers per hour. Kai. Good. So right now, let's talk about this. Now, the rate that they're moving, it's not just the current, right? Because we said the rate of the current is X. But is it only the current moving them? Are they also working? Right? The person in the boat is also working. Right? So we have, or whatever, the boat is doing its own rate. So when you're going downstream, the rate of the current is helping. So when we're downstream, we can travel, when we're in still water, we're traveling 20 kilometers per hour. That's your rate by yourself. But for when you're going downstream, that rate, the current is helping your rate. So you're doing your 20 kilometers per hour plus whatever that rate of the current to speed you up. But now upstream, you're still doing your 20 kilometers per hour, right? But now that current, it's not helping speed you up. What is that current doing? It's now slowing you down. So instead of adding X, what should I do? Subtract X. Philip?
Would it make sense to say that the upstream, I guess, kilometers per hour would be slower, wait, that's not bad, never mind. Forgot. I got the unit, that's all.
You're okay?
Yeah.
Okay. This was km per hour. Is that what you want me to do? Just put my units? Is that what you're saying?
No,
No?
I was gonna ask something else, but then
Oh.
I can't notice that I said something wrong.
Okay. So now let's talk about the time. Well, what do we know about the time? We know the time is going to be the distance over the rate. So here we're going to be 47 over 20 plus x, and here is 33 over 20 minus x. Why is the time column important? Oh, Layla, were you going to have a question?
I was just going to ask, can you go to the bathroom?
Yeah. All right. Why is the time column important? Kai? Because the time is what?
The rate of the current.
The time is not the rate of the current, no. Exactly, because let's say we didn't have this third column. Let's say we just had the first two columns. They're completed accurately, but using these two columns, is there any equation I can make here just from the two columns? No. But if you go back and read, it says in the same time. So we went downstream in the same time it went upstream. So what are we going to do with their time? Set them equal to each other. So downstream in the same time it went upstream. So we are setting them equal to each other. So I'm now going to have 47 over 20 plus x is equal to 33 over 20 minus x. If you solve this, you are going to get x is equal to 3.5 kilometers per hour. That's their rate. Oh, wait, no. Was that what they were asking for? Yes, that's the rate of the current. Yep. 3.5 kilometers per hour is the rate of the current. Okay, there's not enough time to do the independent, but I do want to give you the answers in case you want to try it on your own. So for independent number 1, we're going to have 3 over 2 or 1.5 kilometers per hour. And then independent number 2 is going to be 6 hours. We got those? All right, we're done for today.